Good afternoon, class. We are looking at 2.4 limits, algebraic methods. So we've looked at limits of sequences, limits of functions at infinity, limits of functions at finite numbers, and now limits, algebraic methods. So just to remind you what we've done, limits of functions at finite numbers and finding limits by numerical and graphical method was done. And when we come across this, we read it as the limit of f of x as x approaches a equals L. VA, vertical asymptotes. If the limit of a function f of x as x approaches a, or a from the left, or a from the right, is either negative or positive infinity, then x equals a represents vertical asymptote. When you look at all of these graphs, whether we come from the left or right of a, approaching a from the left, or from the right, whether we approach it from the left or right in the graph, whether approach it from the bottom or the top, we are moving towards this point having the y-coordinate L. In all of these cases, the limit of f of x as x approaches a is L. However, in this case also f of a equals L, there is no hole. In this case, f of a, there's a hole here. F of a is whatever the solid point tells you, which is b. And in this case, there is no solid point, is undefined. We don't know. We are not aware of that. So that's what it says. Part A f of a equals L, part B f of a is equals B, which is not equal to the limit. Part C f of a is not defined, but in each case, regardless of what happens at A, the limit is the same, limit of f of x as x approaches A. So this makes it continuous at A, and these two are discontinuous. Reminding you of the definition of a horizontal asymptote, the limit of f of x as x approaches negative infinity or positive infinity is L. Y equals L represents the horizontal asymptote, and the limit exists if one-sided limits are identical. That means the limit of f of x as x approaches a from the left and right are this. So this is the synopsis of what we discussed. Reminding you of the limit laws, and basically the limit law says if the limit of f of x and limit of g of x as x approaches a, if they do exist and see some constant, the limit of the sum is the sum of the limits. The limit of the difference of the limits. If we multiply it by constant, we take it out. The limit of the product is the product of the limits, and the limit of the quotient is the quotient of the limits. And of course, again, reminding you of the one-sided limit. Direct substitution property indicates a continuous function at A as the following limit value. The limit of f of x as x approaches A equals f of A. Functions with the direct substitution property are called continuous at A. In other words, every function we have studied in the past in pre-calculus, they're all continuous in their entire domain. And that's the key, understanding the concept of a domain when it comes to that. Okay. Let's move on, and we don't have to do this by limit properties or limit laws. Properties or limit laws. But just to show you how it works, we cut it into 3 pieces and 3 limits. This one becomes limit of x as x approaches 4 to the second power. This one negative 3 comes out. This we're going to keep it for now. And the limit law says when we have the limit of x as x approaches a value, that's when we can replace it. So we can replace it with 4. We can replace it with 4. Any constant, the answer is itself. Because this constant is 7, remains at 7. If it were any other number, it would remain unchanged. So now we have 16 minus 12, which is 4 and 7, adds up to 11. We could have simply, plugged in And that's what we mostly do, okay? But we should be familiar with the concept. For example, if we want to find the limit of f of x plus 5 g of x as x approaches -2 in this example 1, we're going to evaluate the limits given the graph. And remember, you guys have access to this. You don't have to draw this under the module in Canvas. You have all the PowerPoints. The only thing that you write is the solution. So you have access to this. In order to answer that, we are going to use the limit laws, and we're going to write this as the limit of f of x as x approaches -2 plus 5, limit of g of x as x approaches -2. And therefore, all we have to do, find them individually. For example, the limit of f of x as x approaches -2. And all we have to do, look at the graph and figure it out. So what would be the limit of f of x as x approaches -2? This is -2. From the left and from the right side of -2, or the f function, the red function, we are moving towards the same point. Remember, the concept of a limit says we don't care what happens at -2. We even, the function may not even be defined, which it is at -2 is the y coordinate of that one. But the limit is the y coordinate of this point, which makes it 1. For the blue function, g of x, from the left side of -2, we are moving this way. From the right side of -2, we are moving this way. And in both cases, we are approaching this point, and this point has a y coordinate of -1. Now, the difference is, since this doesn't have a hole, also g of -2 is the same as -1. So now we plug in and we get -4. The limit of f of x times g of x as x approaches 1, we are going to do the same as this one, and we're going to use the limit laws, separate them into 2 pieces, and we're going to look at each one individually. What is the limit of f of x as x approaches 1? Anyone? What would be this equal to? Here's 1 along the x-axis from the left side, 1 along the x-axis from the right side. We are moving towards this point, and this point has a y coordinate of 2. Since there is no hole, even f of 1 is 2, okay? That's the functional value. What about the limit of g of x, the blue function, as x approaches 1? What happens then? Anybody? The limit of g of x as x approaches 1 does not exist. Why is that? Well, if we approach it from the left, we get to this point, which has a y-coordinate of -2. But if we come from the right side, we are approaching this point, which has a y-coordinate of -1. Because the two are not identical, the limit doesn't exist. Therefore, this limit fails to exist too. One of them exists, one of them doesn't exist. I'm going to show you quickly a second method for that. And that means going back to this, if you want to find this limit, find the limit as x approaches 1 from the left and then 1 from the right. So 1 from the left, what about f of x? F of x, the limit is 2 no matter what, from the left or right. When you have 1 here, that means both sides give you the same answer. That means the limit exists. But g of x from the left is -2. The product of these two makes it -4. What about the right? The limit of the function f of x times g of x as x approaches 1 from the right. Well, we need f of x. We know both sides is 2, so 2. We need g of x. From the right is -1. The product of these two is -2. Since the two are not identical, the limit for f of x times g of x as x approaches 1 does not exist. It gives us the same answer, everybody. It gives us the same answer. Now, to make sure everybody understands what's going on, I want to look at f of -2 again. First of all, the function f is the red one. So f of -2, that means at x equals -2, look for a solid point, this point, as a y-coordinate true. So that is f of -2, everybody. G of 1. At 1, for the g function, the blue function, look for a solid point here. What is the y-coordinate of this point? -2. So we want to distinguish between the limit and function value. Functional value precisely at that point. Limit near the point. What is the limit of the absolute value of x over x as x approaches 0? It does not exist. Why is that? Let's look at it from the point of view of graph, because it's given for now. Why is the absolute value of x over x? As x approaches 0, from the left of 0, we are in this branch. It takes us to -1. So the limit of this function as x approaches 0 from the left is -1, and from the right of 0, we are moving towards this point, which is +1. One-sided limits are not the same. The limit doesn't exist. So that's just looking at the graph. Algebraically, I want to remind you, by definition, absolute value of x refers to distance from 0. Therefore, absolute value of x is x if x is larger than or equal to 0, and negative x if x is less than 0. I hope everybody remembers that, okay? Therefore, when we look at the function absolute value of x over x, this is y or f of x, let's say, then this becomes 1. If x is positive, x over x is 1. If x is negative, minus x over x is -1. And of course, it's undefined when x is 0 because you can divide by 0. And therefore, when we look at the limit of absolute value of x over x as x approaches 0 from the left is -1, as it was mentioned graphically. And the limit of absolute value of x over x as x approaches 0 from the right is +1. Since these two are not identical according to the one-sided limit, the limit does not exist. The limit does not exist. And that's extremely important to know. Let's look at these limits we want to find algebraically. So all you have to do for the first one, just plug in. Can anybody tell me what happens when we plug in number 2? What do you get? Anyone? Anyone has the answer for us when we plug in? You plug in 2 here, you get 2 squared 4. 4 times 2, 8, plus 1 is 9. 3 times 2, 6 minus 2 is 4. Square root of 9 over 4. You take out each one from the square root and you get 3/2. You just plug in and it works. That's all there is to it. Part B. What happens when we plug in? The numerator is 0 if you plug in -4. So is the denominator. And we call this format indeterminate. Please understand. 0 over 0, it's not 0, it's not undefined. It's indeterminate, just like infinity minus infinity or infinity over infinity. And what does indeterminate work? To me, it means more work. What does it mean? More work. What do I mean by more work? Use your algebraic technique. That's the meaning of it. You're dealing with complex fraction. What is the algebraic technique? LCD, the least common denominator. Meaning, when you have a complex fraction, look at every fraction. In this case, we have 1 at top, 2 at top. We don't have any more, only 2. You find the LCD for those two. If we had 2 at top, 2 at the bottom, we would have 4. All of those 4. Okay. I'm going to give you a quick example for you to finish at home. If we happen to have the following complex fraction, let's say 2/3 plus 3 over 5 over 1/2 plus, let's say, 7/3. I have 1, 2, 3, 4 fractions. Okay. And the LCD for all those 4 fractions is 30. So you divide by 30 over 30. By the way, 30 over 30 equals 1. You divide the top and the bottom. Again, this is the only way? No, this is the fastest way. Therefore, for this one, we are going to multiply it by 4x over 4x, okay, which is the LCD. When you do that, what I want you to pay attention to, when we go back to this format 0 over 0, it is the 0 in the denominator that creates a problem. So since x is approaching negative 4, x plus 4 goes to 0, x plus 4 is a problem. So you never distribute, you just keep this as a product of these two. This one you distribute, the product of these two is x, and these two is 4. So the product of those two is x. The product of 1 over x and 4x is 4. Now, as you can see, x plus 4 cancels out x plus 4. You plug in, and the final answer is negative 1 over 16. So it is important to know indeterminate form may end up being 0, infinity, or any other number. It ended up with negative 1 over 16. So go to
For
the,
the right equation, why is are you saying that the least common denominator is 30?
yes. Do you know why?
No.
Because the denominator is 3, denominator is 5, the denominator is 2. They have nothing in common. Their product becomes LCD, the least common denominator of those fractions. Okay. All right. You okay with that?
Yes.
All right. Again, if you plug in, you get 0 over 0. And if you want to find a way to fix that, your algebraic technique would be factoring. Of course, it's easy to factor the bottom. You can take the x out, and the top is in the form of a squared minus b squared, or x squared minus 5 squared, which is x minus 5x plus 5. The other thing I want to tell you, class, because this becomes 0 over 0, and because x approaching 5, we really have a problem with the 0 in the denominator. This means the denominator should have a factor of x minus 5, and it does. If x is approaching, let's say, 7, we should have a factor of x minus 7. If x is approaching, let's say, minus 2, we should have a factor of x plus 2. That should help you with factoring. These two cancel each other. When we plug in, we get 5 and 5, 10 over 5, which is 2. Okay. All right, class, we're going to move on. Any questions? All right, it's time, a few minutes for the breakout room. So I'm going to pause the recording. All right, class. So now that we are back, I hope everybody knows what to do. The very first thing is that we do factoring, and I have mention this, because x is approaching 4, you expect a factor of x minus 4. And you find it here. Okay, that should help you with factoring, everybody. And so x minus 4 drops. And if you plug in 4, you get 4 over 5. Or this one, we multiply by the conjugate. Remember, the conjugate of a minus b is a plus b. The result is a squared minus b squared. Square root of 1 plus h quantity squared minus 1 squared results in this. 1 and negative 1 cancel each other. The h and h cancel each other, and we get this one. What I want to explain before we move on, I've mentioned that before. When you get 0 over 0, and remember, in both cases, as I mentioned it, you do get 0 over 0 here. You do get 0 over 0 over here. This one requires factoring. This one requires conjugate. In both cases, it is the 0 in the denominator that creates a problem. So that's why x approaching 4 creates a problem. So you're hoping to get x minus 4 and you get it out. In this case, h is creating a problem. You're hoping to get it out, and the factoring will do the job. Now, if you plug in 0, this becomes 1. Square root of 1 is 1 and 1 is 2. So 1/2 is the final answer. When we look at this question, I'm going to leave it for you to check it out. If you plug in, you will get 0 over 0. So the technique is the conjugate, and this is a minus b. So you put a plus b at the top and the bottom. The reason you do both, because this fraction must equal 1. So when you want to multiply these two, you multiply the denominators in this fashion, meaning you do not distribute. The numerator becomes square root of x squared plus 9 quantity squared minus 5 quantity squared, which is x squared plus 9 minus 25. These two numbers give us negative 16. And we can factor the numerator into x minus 4x plus 4, because you can rewrite this as 4 squared, which is a squared minus b squared. So the common factor of x plus 4 from the top and the bottom is dropped. We get the limit of x minus 4 over x squared plus 9 plus 5 as x approaches negative 4. And we are going to plug in negative 4. Negative 4 quantity squared is 16. Plus 9 is 25. So the numerator is negative 8. The denominator is positive 10. The final answer is negative 4 over 5.